Hey there, environmental science peeps. So I'm out sick today along with my daughter, so we're home just kind of recouping. But we got a few things that we need to do, and this will take pretty quick. But want to make sure you do have your headphones on, or that you at least you have the volume on too. It's helpful when you can hear it, and I'm going to be explaining a few things here. There are going to be some notes I want you to copy down, things I want you to make sure that you have completed, and then we'll kind of wrap up some other things. But Quizzy Poo is going to be on Tuesday. Test will be next Tuesday. We'll talk about that some more as we go, but here we go. We'll try to make this really quick. First of all, Seasons Lab. You guys did a great job on Friday, but make sure that you have the lab completed and that you also have that diagram at the very bottom also completed. So just kind of make sure you have that, and you can skip part 4. Skip part 4, and but the diagram at the very end you should have completed, and it's really you need to be able to predict what season it is in the northern hemisphere or the southern hemisphere. So if you haven't done that, go do it right now. Pause it. Go do it now. All right. But if you did it, here we go. There are going to be some additional things I want you to have in your notes. You can put this right on your Seasons Lab. Here we got things you do need to know. The tilt of the Earth is 23.5 degrees. So it's tilted instead of being straight up and down, 23.5 degrees or about that. But as we keep going around the sun or revolving around the sun, that Earth's tilt is what controls our seasons. And there's some different points and things that tend to happen, really where you get direct sunlight. So when we're here in December that's coming up, the sun is really kind of hitting most of the southern hemisphere with direct sunlight. And the northern hemisphere is, we say, is tilted away. The southern hemisphere is tilted towards. The axis is actually closer to the sun. When we're in June, that's when the northern hemisphere, the axis is actually tilted more towards the sun, and the southern hemisphere is tilted away from it. But when we're here in the kind of middle, or when we get to September and March, it's neither tilted towards nor away from the sun. These are places where we call them equinoxes. It's when really all the parts of the Earth receive equal amounts of daylight, or really close to equal amounts of daylight. And so those areas, they're equinoxes. The hours of daylight do change. It's mostly at the poles. You need to know that. I want you to make sure that you have all this stuff in your notes. Have all of it. You copy it down. And it tends to be more consistent towards the equator. So it does change a little bit as the year progresses, but hours of daylight, it changes the most near the poles. But because that Earth's tilt and because the daylight hours of daylight change as the year progresses, that's what causes the change of our seasons. It is not distance from the sun. You have to know that. It's not distance. And so I'm going to just type this in here. So not distance. Sweet. And so when we get over here, when we are tilted away from the sun, that is when we are going to be experiencing winter. You need to know that. Down here in the southern hemisphere, that's going to be our summer. When we are tilted towards the sun, that's when we have our summer, but the southern hemisphere has their winter because they're tilted away from the sun. Spring and fall tend to happen here at the equinoxes. But that's what you gotta have. You should have that in that diagram from the Seasons Lab. Yeah, you should have that. But if you need to get that in there, make sure you get that in there. Okay? But that's what you need to know about the seasons. That is on your quiz. We'll take that on Tuesday. Okay? But here we go. Other stuff. We're going to change gears a little bit because yeah, we were talking about our seasons and how Earth gets heated up differently, but we want to really kind of start moving towards which direction do most of our storms come through in Minnesota. Like if you hear about tornadoes or most storms, it's like uh, which direction they come from. Really, they tend to come from the southwest. They tend to move northeast. It's like, why do they do that? Well, there's going to be some pieces that we'll be putting together in the next few days to explain why do they move from the southwest to the northeast. Uh, and one of the things is that causes it is convection. I want you to say that word, convection. But convection, what it is, and we're just going to define it here in just a little bit. But I'm going to play this video for you really quick. And this video shows what convection is. So they have a tub of water, and inside there, they're going to put two different types of food coloring. Red food coloring here in the middle, and blue food coloring on the sides. You'll notice that the water or that food coloring does want to spread out, but they're going to do something kind of interesting. Underneath this red one, they're actually going to put some warm water so that it actually starts to heat up that central spot right underneath the red food coloring. But when it does start to heat up, you'll kind of notice this, is that the red food coloring, because it's actually warm, it actually starts to rise. That heat wants to actually kind of spread out, but hot water and hot air, they tend to be less dense. Things that are less dense, they actually rise up above other things. But because it's rising, it actually gets replaced by cool water or cool air. And that ends up creating these circular spots where it ends up kind of mixing around. But this movement of hot and cold parts, in this case it's water, same thing happens with air. That's what we consider convection. And it's that movement of hot and cold. Hot stuff rises. Cold water and cold air, they tend to sink. But that's kind of the gist of it. So that's something that you probably have seen before, and it is based off of density. Warm air, warm water, they tend to rise, and because they are less dense. Cold air, cold water, they tend to sink because they are more dense. But here's the things that you need to know. In this diagram, please don't write down the diagram yet. We will do this together later. But global winds are really driven because of the unequal heating from the earth. We kind of saw that in the seasons lab, is where it tends to be hotter when it tends to be cooler because of the tilt of the earth and where the direct sunlight is. But as that hot and cold air, because it's uneven, it tends to move, and that's convection. And it's trying to really balance itself out, balance the hot and cold areas. So warm air rises, cold air sinks. This is the stuff that you need to know. I want you to have this in your notes. Okay? But again, the how that hot and cold air ends up kind of moving around, there are some different things, especially here in the atmosphere where it tends to be warmer, more towards the equator. That's when the hot air rises, and that's where this arrow is going. And then once it rises up, that's where it tends to be cooler in the atmosphere. The air cools down, and it tends to travel up, and then it sinks down later once it's cooled. And then it replaces where the hot air was. And you end up with these different cells that happen throughout the earth. There's cells called the Hadley cell. You don't need to know the name, but it tends to have convection currents here. The Ferrel cells tend to happen kind of at the mid-latitudes. And then the polar cells is when you have a lot of cool air, but you still have convection occurring because hot air will force some of that air back up. And then it tends to be coldest at the poles. That's where it's going to sink. And so we end up having lots of things that happen around our Earth, and it's all from convection. And so that really kind of takes care of what you need for your notes. I want you to make sure you have it. But then last thing is I want you to go and check your test 2 scores. You will find it in your email. You'll see the scores. You'll also see feedback. If there was anything that was kind of marked off, please check it, because some of them will say, see Mr. Broberg, where you have to be a little more specific. Please check it. But do corrections. Do it on a separate sheet of paper. Give your answer, what the correct answer should be, and a reasoning why. That kind of lets you get to taking the retake. The retake does not take that long, but we will talk more about that tomorrow if that's something that you're interested in. You can do that during win times this week. I should have win times, and I should be back tomorrow. But we'll kind of, yeah, that's kind of where we're at. Then, make sure that once you have everything done here, you have the notes for convection, the notes for the seasons. Please turn this assignment into Google Classroom. Take a picture of it with your notes. Submit it today. I'll be checking that. I'll be updating it. And then just show me. You'll in there. You'll be good. And I hope you guys stay healthy and have a wonderful day. It's snowing outside. All right. But I'll talk to you later.